record on this computer. All right, I'm recording. All right, so I'm going to create a tree object that has different attributes about it. So I'm going to create two files, one called tree.py and tree.py. And what do most trees have on them?
Leaves.
Leaves. So I'm going to create a leaf.py file. And I've got a tree and a leaf. So I'm going to create, so trees have multiple leaves, right? So you can think of each leaf being an instance of a leaf object. So, and a tree can have multiple leaves on it. So a tree can have multiple leaf instances or multiple instances of a leaf object on it. So I'm just going to create a class called leaf. It's very simple. And there's really not a whole lot we need to know about this leaf object. We can just return, it can be instantiated with self.init. And the only thing we really want to know about it is like the size of the leaf. So we're scientists or whatever, and we want to know like the length of the leaf or something like that, just for this purpose. So self.size equals size. And we'll say, we'll have another method just says returns leaf size. Pretty straightforward. And the only thing it returns is the self.size. Very simple. So anytime we pick a leaf off of a tree, we can look at it and see its size. That's pretty much all we need to know. But now, I'm going to hit over here, I'm going to split the screen. We have a tree. And a tree is a little more complex than a leaf. So I'm going to create a class tree. And this tree is going to be instantiated def init self. And what we want to know about this tree is maybe like the tree type. So whether it's an oak, maple, you know, whatever. So it's the tree type. So we can do self dot tree type equals tree type. What else can we know about the tree? We can know the age of the tree, perhaps self.age. So when we initialize a new tree, it'll be, the age will be 0. And trees have leaves. So within this tree object, it's going to have multiple leaf instances. I'll repeat this. When we initialize a new tree and the tree ages and the tree grows leaves, it's going to create new leaf instances. So as the tree as it grows leaves. And when it's initialized, when we initially plant a tree, self.leaves, it's not going to have any leaves on it. So we're just going to leave it as an empty array. And this leaves array is going to be filled as it grows with leaf objects. What questions do you have about that kind of logic right now?
I have a question again.
Yep.
So the leaves, the self.leaves array, it doesn't need to be a class variable because the leaf is going to be like a member of the tree. And so for each instance of the tree, it can store multiple leaves, I guess. Correct.
So it won't be a class variable because each tree might have different numbers of leaves on it. So that's why it's an instance variable. All right. So let's just go over here for leaf and just new leaf equals leaf. And we pass in a size of 6 and print new leaf dot return leaf size, like so. And down here, I'm going to print or run the leaf py file. Great. So I just want to make sure that the leaf object works. So I just created a new leaf right here. But as when I initially plant a tree and it starts to grow, it's going to, as a tree grows, it's going to grow a number of leaves. So I'm just to create a method called def age tree. It takes in self, and it's going to increase the age by 1 every time. So I'm going to create a new tree instance called like oak tree, and create a new tree instance and pass in oak because that's the type of tree it is. And I can print oak tree. And now I'm going to run the tree file just to see if this oak tree is created. All right, we have a tree object, great. But every time we age the tree, we want the tree to grow a number of leaves. Or, yeah. So let's just keep it simple for right now. Every time the tree ages over a certain age, so maybe after the age of 2, it will grow a leaf. It's a really slow, we're not good at taking care of this tree, but so let's say every time the tree grows after the age of 2, it grows a new leaf. So we can say every time we age the tree, if self.age is greater than 2, it grows a new leaf. So we have this leaf instance or leaf object over here. So the first thing we need to do is import, or from the leaf file, import the leaf object. So right now, I can create a brand new leaf by calling the leaf. And let's just keep it simple. Every single leaf, well, we can actually make it a little more fun. Import random. We can create a random integer between like 1 and 6 or 1 and 5. Oh, shoot. Built in. 1 and 5. So every time I age the tree, we can create a new leaf like so. And at the very end, I'm going to return just the self.age of the tree because that's what I want. So print dot age. So this first, so I created a new oak tree, and now I'm going to age the tree 1 year. Let's see what happens. So now I've aged the tree once. I'm going to age the tree again. So I'm going to age the tree 3 times. Year 1, year 2, year 3. Cool. So that's the age of the year. But now at age 3, I should be creating a new leaf instance and adding it to the self.leaves empty array. So I'm just going to print new leaf here just to make sure it's created when right here, when it reaches age 3. There we go. So there's that new leaf object at age 3. What questions do you have about the logic of every time I age the tree, after the age of the tree is 2, I create a new leaf object?
Is this going to overwrite that same object every time?
So every time I run this,
Yeah, the leaf object, like the new leaf is going to be, you only get like one new leaf basically.
oh no, so like essentially every time I run this, it's going to like add a new leaf. It's going to create a new leaf. So yeah, right now it's just creating one new leaf every single time. But we want to store these leaves on the tree. So right now I'm just creating a new leaf. I'm not doing anything with it. It's not actually stored on the tree. So that's where the self.leaves array comes in. I can officially add the leaf to the tree by doing self.leaves.append new leaf. So every time I add, like I'm aging the tree a bunch of times, it just created a bunch of, it's aged 15 years. Now let's create a method that returns the number of leaves on the tree. Def.get number of leaves. So how many leaves, how do I determine the number of leaves on the tree?
The length of that self.leaves list.
Exactly. So I can return the length of the self.leaves array instance variable. So,
what does the array that holds all the leaves look like? What kind of data is it storing in there?
we'll check that out right now. So I'm going to actually get rid of these print statements because I don't really need to know the age of the tree. I just need to know. So I'm just aging the tree. And now I can actually just print. I'm going to print that instance variable, oak tree dot leaves. So I'm directly accessing this leaves instance variable. So if I clear the console and I run this, it is an array of object instances. Right? So what questions do you have about storing an array of object instances of the leaf object?
So why isn't it an array of leaf sizes with random numbers between 1 and 5?
It is. So watch this. I can, well, because it's an actual object of a leaf. So think of it as an actual leaf where this is being stored. So within each leaf object, I have access to the size. So let's just say get or define, I want to create another method that says print all leaf sizes. So how can I print the sizes of every single individual leaf in this array? I can say, does anybody?
Oh, could you loop through it and say, like, loop through the leaves object array that you have in that method and say, like, for, objects in leaves, trying to think of how you'd say that you print, like, objects dot return leaf size method or something like that.
Yep, exactly. So I have access in this each leaf object instance, I have access to all this information. So I can say for leaf in self.leaves, I'm going to just print the leaf right now. Print the leaf and see what that looks like. So, right, delete that and do oak tree dot print all leaf sizes. I'm going to come down here in the console and clear it. And now I'm literally just printing all the leaf objects. Now, instead of doing that, I can print the leaf. This individual leaf is this leaf object. Now I have access to all these methods off of this leaf. So leaf dot return leaf size and invoke it. Clear. Now I got all the different sizes of each individual leaf on my tree. And this can be literally called like anything. I'm just explicitly calling what this is. So what questions do you have about these objects interacting with one another?
Is it beneficial to keep them in separate files like that for like cleanliness sake?
Yeah. You don't necessarily have to, but yeah. So say a scientist wants to know, like, is it looking at different trees and that wants to know explicit data from a tree. So let's grab the average leaf size on that individual tree. So I can say average leaf size. And now I can actually do like total equals 0. Again, for leaf in self.leaves. I can total plus equals run this return leaf size of each individual leaf. And then at the very end, I can grab the average by doing equals total. So this is the total leaf size added up divided by the number of leaves on the tree. Now I can actually return average. So I can print average leaf size of the tree. 3.3 inches, something like that.
Tom, I notice in your in I guess all of these, you're writing like the leaf dot returns leaf size. That leaf is a lowercase l.
Yep.
Is that related to the class leaf that you have over on your right side of your screen?
No, it's literally only it's related to how I am declaring this loop. So I can literally say for anything clear and run that, and it still works.
I see. And so can you just walk through real quick how it knows in line 29? Where is it pulling returns leaf size from?
So in self.leaves is an array of objects. So
and each of those objects has a return leaf size.
Yep. So print oak tree dot leaves. So each one is an instance, a leaf instance. Get the hell out of here. And I have access to all those, all the attributes of this leaf object.
And you could also have color and width and all the different stuff in there too.
You can add, you can do anything you want in here. You can add more attributes to the leaf. You can say color,
Okay.
All that stuff. But I just kind of want to keep it kind of slim and small for right now.
Yep. Thank you.
Yep, no problem. What are the questions? So again, I've got the average 2.1 inches, whatever that means. So I can even create like a new like apple tree or, you know, maple tree, maple tree. So I've got a maple tree and an oak tree. And I'm like aging the oak tree right here. Aging oak tree. Aging maple tree. Maple tree dot age tree. Do all that, age it enough, and I can compare like the oak tree average leaf size and the maple tree average leaf size. I can even say like average leaf size for self.tree type is, yeah. So I can clear that. So average leaf size for oak. Let's run that again. There you go. So that's exactly the same. So average leaf size for an oak tree is 3.0 inches. Maple tree, it's 2.88. So this is where I just wanted to like show you how objects interact with one another. So you can call and create a new instance of an object within another object. So in this tree object, I'm creating a new instance of leaf, and I'm appending a new leaf to like self.leaves array, which is an array of leaf objects. So what questions do you have about objects interacting with one another? Because today's challenges and pretty much the rest of the week, you're going to be creating multiple objects that interact with one another like so. Nobody has any questions?
I actually have one, Tom.
Yep.
I think I've heard the term relational objects from people before. Is this what they were talking about?
I actually do not know.
Okay.
I've never heard the term relational objects before.